guys. So today is going to be another calculator heavy day. So if you have your calculator, go ahead and grab it because you're going to want it for today. Today we're actually going to use something that you've used already this year, and that is regression. So we're going to use regression to determine the best fit model for an exponential function. But before we do that, we're going to do some non-calculator stuff. So the first thing we're going to do is just determine what type of data we have. We've looked at a lot of different types of data sets so far this year. We've looked at linear, we looked at quadratic, and now we're looking at exponential. So it's important for us to be able to tell the difference between those things. So one thing that we can do is by looking at a table, if our x values or our inputs are spaced evenly. So we check that first. Okay, if they're not even, then we need to find the intervals where it is and only consider those y values. So here, those are all my x's, those are all going up by 1, so we're good. Now what we do is we look and see how are those y values changing. Well, let's look from 0.5 to 1, 1 to 2, 2 to 4, 4 to 8, every time I'm multiplying by 2. So if I'm multiplying by 2 each time, we have what's called a common ratio. And that common ratio tells us that this is an exponential function. When you guys get to series and sequences and pre-cal next year, you're going to see some of this come back up as well. All right, now let's look at B. Again, inputs are evenly spaced, so we're good. Now let's see what's happening on our y's though. From 2 to 0 is minus 2. 0 to 2 is plus 2. Plus 6, plus 10, plus 14, plus 18. So I don't really see a pattern here. This is one we actually did earlier this year though. If you remember, if the first differences weren't the same, we looked at kind of that change of the change, okay, the second difference. To get from negative 2 to plus 2, we've gone up 4. To get from plus 2 to plus 6, we've gone up 4. And each time, we're continuing to go up 4. So because those second differences are the same, that shows that this data is quadratic. All right, on this next one, see again, inputs are evenly spaced. Each time I'm subtracting 3. Adding or subtracting a common number, that's called your common difference. Again, that'll come back up when you get to series and sequences later on, but that shows linear data. All right, so it's going to be just a straight line. And then looking at this last one, did I write linear? I did. I'm dividing by 3, but another way to look at dividing by 3 is multiplying by 1/3. So this is still exponential data. All right, so what we're going to do now is we're going to do a little bit of algebra, and we're going to review systems of equations. So it says using algebraic methods. That means not using the calculator. We are going to do some calculator stuff here in a little bit, but I want to make sure you guys understand algebraically how we can work this out. So what we're going to do is write an exponential function in that y equals ab to the x form that goes through those points. So what I'm going to do is I'm going to write a system. So 1, 6 is an x and a y. So I can have an equation where 6 equals ab to the first. I can have another equation with that x and y where 54 is equal to ab to the third. And then all I need to do is solve this system. Well, substitution is going to be the easiest method here. If you look at this first equation, it's pretty easy to get either of those variables by itself. You can get a or b by itself just by dividing. I'm going to go ahead and get a by itself. So a would equal 6 divided by b. I'm going to plug that into this equation. So 54 is equal to 6 divided by b times b cubed. Well, if I do b cubed divided by b, I end up with b squared. Divide by 6, square root. And we don't need to worry about -3 here, because remember, that base has to be a positive number. Okay, if we don't have a negative as part of the base, because it's not really an exponential function, you're just kind of going to bounce up and down if it is. All right, now that we know b, we can take that, plug it back into either of our originals, and I get my a value. So that means this equation would be 2 times 3 to the x. Remember, that is not the same thing as 6 to the x. Okay, I cannot multiply those two things together because only the 3 has the exponent. The 2 does not. All right, let's try this again. So same idea, different numbers. So set up two equations. So 1 equals a, b oh, I flipped those, sorry. 10y equals ab to the first. 40 equals ab to the third. Solve for one of your variables. We'll go ahead and solve for a. A is going to equal 10 divided by b. Plug it in. So I end up with 40 equals 10b squared. Divide by 10. And I get b equals 2. Now that I know what b is, take it, plug it back into your original, and I get that a equals 5. So my equation would be 5 times 2 to the x. So this is how we solve it algebraically. Now you will see this on your practice questions. You will need to show the algebra on those practice questions. There's only 2 of them, but you will need to actually do the math and show the work on it. The other way that you can find an equation that has exponential data is using regression, and that's what we've done a couple times so far this year. Now, as long as you have 2 points, you can do regression. The only problem is with 2 points, you also can write a line that goes to those 2 points. So if you're only given 2 points, you need to be pretty clear about what type of data that you have. But if you have multiple data sets, like this next example, then we can tell a little bit clearer what this is going to look like. So your regression steps are listed on your notes if you don't remember, but go ahead and grab a calculator. All right, so your steps here, you're going to go to menu, and then you're going to go to statistics. Then in list 1, you're going to type all your x values. In list 2, you're going to type all of your y values. So I've already gone ahead and typed those in. So now if you don't know what kind of data you have, a good idea is to start with the graph option. So if you go to F1, then you can see our graph. Go ahead and go to graph 1. And that's going to show you that data. So if you look, it's starting to kind of increase as it's going on. So this is not linear. It could potentially be quadratic, but we're going to go ahead and find an exponential model just to get some practice with that. So there's 2 things you can do. From this screen directly, you can go ahead and go to Calc. And then you don't see exponential, so we're going to go to F6 to see some more options. And now we see EXP for exponential. Now you'll notice there's 2 different options. I've got AE to the BX and A times B to the X. So you can use either of these equations. AE to the BX is going to be kind of that continual growth model. You use that a lot more in pre-cal. So we're going to stick with the AB to the X model because that's what we've been using most of the time. Once we do that, we see our equation. So it gives us the value of A. We'll go ahead and round to the nearest, we'll go ahead and round to the thousandths. So we'll do 8.457, and then B is going to be 1.419 to the x. And remember we talked about this back when we were in regression for quadratics. The closer that r squared value is to 1, then the better that model is going to be. So that's pretty close to 1, so it's a pretty good model. The question, though, is do you think that this is a good model to predict the number of trampolines that are going to be sold in the 15th year? So this is when we really kind of need to think and kind of need to analyze the situation that we have and kind of justify our decision. Well, if we want to know what it is after the 15th year, I would just plug in 15 for x. And I can plug that into run matrix, or if I want to get kind of that exact answer, I can copy this equation into my graph. So now when I go back to my graph, well, I went ahead and drew it. So let me go back. So now that equation's in there, I do need to, I'm going to scroll over so that I can press enter. And now I have that equation in my graph. So if I want to go ahead and graph it this way, I can. I can do gsolve. And then since we want to know 15th year, 15 is an x, so I'm going to do a ycal and 15. And I'm going to make my window bigger so I can make sure I actually see it. So if you get that out of domain error, go to your window. So Shift F3. And I need to make sure my x's are at least as large as that value I'm typing in. So if I'm typing in 15, I need to make sure my window is at least that big. There we go. So now I'm going to do gsolve ycal. And then you see that's about 1,608 trampolines. So our other question then really is that reasonable? And this is where we really need to kind of justify our answer. A quadratic model may actually be a better fit for this particular data. Let's go ahead and go back to it. Just because if you think about this and how many trampolines they're selling, in the first 7 years of existence, this store hasn't sold over 100 trampolines. Now all of a sudden, in twice that time, it's going to be selling thousands and thousands of trampolines. It may be possible, but it may not be realistic. And that's, again, this is where you can really justify your reasoning for your answer and kind of explain why you're picking the model that you are. So again, if you look at that graph, we could probably find a quadratic model that models that data better. It's just a matter if we think that this graph is going to do more of this, or if we think that that graph is going to kind of have that same kind of gradual parabola type curve to it. So two different ways that you can really look at it. It just kind of depends. Again, so we just really need to kind of justify your answer. But the biggest things to really get for today is just how to write that equation, how to determine what kind of data you have, and then again, just reminders of how to use that regression. Again, for regression, if you go back, let's say you didn't want to look at the graph. Let's say you knew that that equation was going to be exponential. Then instead of looking at the graph from that status screen, you can go straight to calc, straight to reg, and then straight to F6 and exponential. And you can still get your equation that way. So you really have two different options in how you could do it. All right, so that is it for today. You got a couple of practice problems to work. Again, make sure on the ones where it says to use the algebra, you show the system and you work those out algebraically. Also on the tables where you're supposed to determine what type of data you have, make sure you give a reasoning or show the explanation for why you're picking what you're picking. All right, again, if you have any questions, feel free to email me. But again, there's your to-do list for today, pretty similar to what you're used to. You've hopefully already done that Ed puzzle. Do your practice problems. Again, show your explanation, show your work. If you have questions, you can email me, do that video request, or join that Zoom session. And then don't forget, you got that week 4 assessment. It's really just going to combine what we did on Tuesday with what we did today.